aren't enough of you, because there aren't enough pairs to get up to 15, so do it again and put the second set of results up there. What'd you do? My cat climbed up in my lap the other day and got close to my computer and shocked my computer so badly that it shut it down. It's fine, but it's like I have to restart my computer. Misty, because she's gray. She's gray like a little cloud of floof. Has everybody done this twice? Not everybody.
Oh, wow. We got the highest.
All right, I need, 3 more groups to do it again. I don't care which 3. Now go into your computers and open up an Excel file and put the data in, just like I'm doing on the board. I figured that was a 3. I think I got that down correctly. I need one more pair of numbers.
Just make a new Excel file.
Yeah. I'm going to name mine something simple like cards. Somebody draw some cards. Okay, all right, good. Awesome. Yeah, 5 and 12. So once you have your Excel file built, save it, and we're still talking about the central limit theorem and 95% confidence intervals and how all that stuff works. And for whatever reason, this guy doesn't want to turn on. Seven 5 3 10 10 2 8 2 7 3 2 4 12 7 8 7 5 10 5 2 1 2 1 13 10 11 7 10 5 12. Okay. All right. So once again, give it a simple file name. If you have your computer, or if you're working on a Windows machine, go ahead and close out of that. Save that in a place where you can find it, maybe in your R intro file. Go and open up R. Open up a new R script, and you want to read that file in. Oh, I forgot to do one other thing. Save that not as an Excel file, but save it as a CSV file. So I'm going to have to open mine back up because I closed. Oh, there, it's already open. Okay, all right. So when you go to save this, you save as, and down here, it gives you options of how to save it. Go down until you find comma-separated values files. I save files as comma-separated values files because it'll read Excel files in, so you could do read.xls, and it will read in Excel files, but sometimes that's a little glitchy. Sometimes it doesn't read in correctly, but it almost always reads in comma-separated values files correctly.
Is that the same as like CSV and then in brackets, comma delimited?
Yes. So you're going to read in, so the first thing you should do is make sure that you're in the right directory. Yeah, so let me show you again. Don't save as a template, cancel. Save as. Down here, there's a comma delimited that is a UTF-8 file. Don't use that one. Go down further to just a plain comma separated values file. It's an older file format, but because it's older, it's also more stable. It's the thing about getting old. You're stable. Yes. Uh-huh.
How do we save it like that?
Oh, yeah. So go up to File, Save As. No! Why do you not have a Save As option?
Probably.
That's weird.
I already saved it as an Excel.
That's fine. That shouldn't matter. Go to Save a Copy. Oh, yeah. I guess they've changed the wording. Go down there. And go down there. All right. Cool. Sure. And then just hang out if you've done that correctly. Yeah.
I didn't get any. Oh, wait.
Whoa. You're moving too fast. Save as. Oh, interesting. Click on that, see if it does anything. All right. Get out of that. Go back up to save file. Give me a minute. All right, just save it as an Excel file, and when you do your read command, just do read XLS, and we'll see how that works. Okay. Everybody up to speed? No. Well, just give me a minute. I'm working on getting people to save things correctly.
I'm in R. Now I need to
Get a new. Go up to new.
here.
Nope. File new.
Oh, okay.
New file, an R script. Start a new R script. Anybody else? Yes, ma'am.
Can I get rid of this from the previous?
No, that just loads whenever you load R.
Okay, so it's all.
Yeah, you're good to go. Check your working directory so you make sure you know where you are relative to where your data are. So the first thing I always do in my scripts is I always get WD. Whoa. And I'm in January 24th materials because that's where I happen to put my data. So then you want to read in that data file. So whatever you called your data file, I called mine cards. Once again, put it in quotes. And I got the no such file or directory, so it's an object not found thing, so I need to make sure that my data are in the right place. Oh, I didn't save it as a CSV file, evidently. I was showing you guys how to do it and then didn't do it myself. Oh, I see what happened. All right, was everybody able to read in their file? Not yet, okay. Once you read it in, display it, just type in DAT, and
I usually don't work on these, but my computer is dead, and I'm really.
oh no, your computer's dead. Okay.
I can't find the file that I saved.
Okay, get your working directory. Yeah, you have to run it. Just go up to that line. Just go up to the line. Well, you can do it that way, or you can also do Control Enter. So get your cursor in the line. You can also arrow key it also works. Control Enter. Okay, so this tells you where you are. Is that where your data is?
I think so.
Okay, so then try reading it in. Whoa. That's weird. Yeah.
I'm having problems with mine. I just changed the name though.
Okay.
Run
it, see if it works. You don't have to highlight the whole thing. Okay, no such file directory. Give me your working directory. Nope. In R.
Oh.
Run get WD. Show me your working directory. Okay. So you're in users Austin. Show me where your data file is on your computer. Oh, so that's in the R intro folder. Okay. So
Yeah.
So what you need to do is, where's your, oh, this is it. Right click on that. Go to get info. Go to where it's at. Go start here at users. Copy all that from users to the end. Well, copy all of that. You'll have to edit it. Okay, copy it. Go back to R. Give yourself a line. Set WD. Open parentheses. And now in quotes. Now type that. Yep. Okay. Now run that line. Just from there, you can just do command. But anytime you're in the line, just do command enter.
Okay, good enough.
So now that's your working directory.
And now I can run this one.
Wait a minute. No, run that again. Oh, we wait. Oh, sorry. Get WD. So now you're in that thing. So now try and read in the data.
Said
Command enter. Command enter. All right, that looks like it read it in. Yeah.
Okay. So, you can't find it?
Okay, show me your working directory.
Run
get WD. All right, everybody, we're rusty already on R. Get WD. Get WD tells you your working directory. When you get whatever this returns to you, it's going to give you a path to a file, a folder on your computer somewhere. Go and then look at your data file that you just made in Excel, find the path to that. If the path to that, using get info or properties if you're in Windows machine, if that path doesn't match this path, you then need to set working directory, put the path to your data file in quotes and run that, then get WD again to make sure that it changed that directory. Then you should be able to read in your data file, okay? So,
Yeah, it's on there. It's my working directory.
okay, let me see.
Then
So this is, copy that path. Your mouse button is set up differently than mine. Okay, all right.
I have it in, but
Okay, so that's in there. Oh, get rid of the Macintosh HD. Start 8 users.
really,
Yep, just delete. And put that back in there. Okay, now try that. Oh yeah, now get WD, see if that worked. It did.
Yep.
Okay, so now try and load your data file. All right, who else? I think I need to break out the sticky pads. Do I need to break out the sticky pads? Okay, all right.
It's still not finding it.
Okay,
I'm
so
not sure if it is there, but I can't like find it to check where it is. I have a charger to this, but
oh, do
is
you?
there anywhere to plug it in?
Yeah, there should be a plug-in space right below you in that hole.
Not really.
Yeah. Yeah, better for you to work on your computer that you're used to. Yes, ma'am.
Okay, I tried to do what you did, but then it keeps telling me error.
Cannot open file. Yep. So hmm?
I pulled up the where it's
Oh, because it's on the iCloud. R doesn't like iCloud for whatever reason. Save it onto your hard drive.
how do I do that?
You have a hard drive on your computer.
Do I go back to the
Save as, yeah, sure. Okay. When you save as, click on that little down arrow there. Okay. All right. Go to your Finder. Go to Finder Properties. Preferences. Yeah, Preferences. Show me your hard disks. There you go. Okay, this is where you want to find it. Make yourself a folder inside of users. Make yourself a folder.
How do I do that?
Just go over here and right click, new folder. Name that folder, I don't know, stats or something. Okay. All right, get the path to that. Copy that path and set this as your working directory. Actually, it's going to be, yep, go ahead, go back to R. Cancel that for now. Now use this as your set working directory. Type in that path. Okay, now wait, no.
Oh, sorry.
Type in the path. Yep, quotes, path, / stats, because that's what you named it, right? Was it upper level or, okay, all right. Now, do that. Get working directory, see if it worked. Get working directory, see if it worked.
Do I just type in this?
Nope, just you can just command enter right there. Okay, there you are. Now go and save your data file to that directory on your hard drive. Yeah, what's that?
I wonder why I saved it as a regular CSV.
Oh, yeah, because that's what a comma separated values file is. Yeah.
So it's okay, it looks like this when I read it in?
No. No, not at all.
That's what it's showing.
Okay, where's your original Excel file?
Right here. This one.
Okay. Did you put it in like this?
No.
Or did you put it in columns?
Like a regular.
That's weird.
Like that.
So show me your R script. Go back to Excel, re-enter those data.
Drag that.
Yeah. I'm not sure why it did that to you. Anybody else? Yeah.
For whatever reason, it's not letting me read this in.
Okay.
Even though it's in my directory, it's in there, it's been saved as a CSV. Oh, do I have to do .csv, right?
Yeah, .csv. Yep, that's the full file name. That's the reason. Boom.
Perfect.
What did you want me to say this into?
Save it into the directory that you just saved it into. So click on this thing here. Oh, okay, go back. See, it's saving everything to the iCloud. Where's your hard drive? All right. Yeah, yeah, thanks. We see it. We just, all right, so cancel out of this for just a minute. Let's go back to Finder. It's not appearing in there. All right, let's go back to Properties, Preferences. Sidebar. Okay, let's see what that did. Ah, there it is. There's your hard drive. Woo, there's your hard drive. Okay, all right. So now let's go and save. Save this. Try and save it. Save as. Now, there's your hard drive. Click on it. Click on Users. Click on Stats. That's where you want to save it.
Okay, thank you.
Boom. Okay, now try and read that in.
So do the,
Just do the read CSV. You've already got it there.
so do we do that?
Yep.
Okay, now look.
Yes.
I'll just save it.
Okay. Let me see what happens when you save it. So first save it as an Excel file so you don't lose the work.
Okay, so Excel work right?
Yep. Save it. Okay, so it saved it that way. Now try and save it as a CSV file. Overwrite it. It worked. Okay, now try reading that thing in.
Okay, I gotta exit out of this.
No, it makes you exit out of it before it'll let R read it, R use it?
That's
That's weird.
refresh.
No, just go to where is it in your script? Where is your script?
Okay, here. Script.
Oh, edit up here and then execute up here. This is your editor window. So do the where is your
The data read.
yeah, just copy that and paste it up here. That way it's always up here and you don't have to go find it again and you don't have to retype it. There you go. Is that the name of your file?
Yep.
Okay. See if that works. It didn't do it.
We gotta actually physically type it.
No, you shouldn't have to. Oh, wait. How did this get in there? What is that?
You are. I have no idea what.
Oh, yeah. So you just close that window.
This one.
Yeah, click the X.
So
Don't save it. Okay. Here's your file.
Right.
There it is. Okay, that's why I could. Okay, now look at it. Just type in DAP. Oh, there it is. Okay, awesome. Yeah.
I'm trying to set the working directory and it's saying it cannot change it.
Well, that's weird because you're telling it to change it. What is your current working directory? Show me your Git WD.
Users play.
Okay, run set WD again. Nope, just run that same line. let me see your file structure. So go to your Finder window. Okay, all right. Click on desktop. Right click and get the path. Wait, stop. Oh, where is your path? That's weird.
I
Okay.
had found it before, but I think I couldn't find it.
Okay, find the path there. To any of those files. Right click. Get info. Ah, you're on your iCloud. Okay, I'm going to say this again for the 1000th time. For whatever reason, R doesn't go and get iCloud things, and I think it's because of protections in iCloud. If you're doing all of your work in iCloud, you're going to constantly have trouble accessing it. So you need to create a workspace on your hard drive on your computer. All of your computers have hard drives on them. It's not necessary to store your entire life in the cloud. So this is the problem. You are storing everything in iCloud, and so it's not giving you the path. So
I didn't mean to start.
well, no, I know you didn't, but the reason we had the conversation early on about kind of the structure of your computer was to avoid these recurring issues. So try copying that path. Try copying it. We'll try this. Now put that into that path. Right, now try that. Is that going to work? That did work. Okay, now try and read in the file.
Can I just go back?
Yep. Now let's see if it did it.
How do I do that again?
Just type in DAT. D-A-T. Yeah, it did it. All right, she managed to access iCloud. For the rest of you, I'm not sure what's going on with getting it through iCloud. So what are you getting? CSV not found? What's your working directory?
Users find a bar received that from one document.
Okay, is that the same?
Yeah.
Oh, that is. Okay.
And then,
That's an Excel file. Save it as a CSV file.
I thought I did.
Save as?
This?
Nope. Just plain CSV.
Okay.
There you go. That will fix it. Now try it. You got it?
Yeah.
She's got it. All right. Sorry, I didn't mean to throw R at you unexpectedly. And unfortunately, all my sticky tabs are in my other bag because I've been walking to school lately, so I've got my backpack rather than my satchel. So you're just going to have to raise your hands when you need a hand. Everybody have the data file loaded up. All right. You know? All right. Let's see. What do you have?
I saved it.
Okay. All right. Go back to R. Let's see what you got. Run get WD. Just let me see where you're at. Users. Phone number. Documents. Okay. Oh, it's not in quotes.
Okay.
Put cards.csv in quotes. Now try it. Nope. All you need is that line. Here's another thing that I see a lot of you doing. You think you have to have the whole line of code highlighted, and then you guys are clicking run. Just put the cursor anywhere in there, and if you're on Windows machine, Control Enter. If you're on a Mac, Command Return. So much easier than highlighting the whole line, clicking run. You don't ever have to highlight the whole line to get a line to run. You just need the cursor to be in the line of code. You'll save yourself a ton of time. Also, if you don't quite hit Control Enter, you didn't press Control down, and then you hit Enter, and you have the whole line highlighted, it will erase that line. So whatever you just typed in, you'll have to retype, or you'll have to hit the undo button. So that did it. Now do that to see if it worked. And you might as well just do it up here so you can save it later. Now run that. Yeah, there it is. Okay, cool. All right. All the monitors were on earlier, and now they're all off. Why? They were on earlier. Okay. Okay. Now I have to get caught up with you guys. Okay, so what we have down here, we were talking the other day about the central limit theorem, and one of the cool things about the central limit theorem is it basically says that if we go to a population, we pull a couple of observations out of that population, calculate the average of those couple of observations, do that 1,000 times, build up 1,000 sample means from that population, it will give us a distribution of sample means that will be normally distributed. And because of this, we can then use the empirical rule to help us put 95% confidence intervals on that sample mean. So one of the reasons that we might want to do this is because we might want to be interested in using the sample mean to tell us something about the population mean. Because when we went and we calculated a 95% confidence interval the other day, I asked ways in which we could interpret the confidence interval. And I forget who was it. It was you, wasn't it? What's your name? Will. Will basically said, inside the 95% confidence interval, so the 95% confidence interval is the mean in the middle, the mean plus the t-statistic times the standard error on one end, and the mean minus the t-statistic times the standard error on the other end. And within this range of values, you have a 95% chance that the population mean is in here. And that's a perfectly reasonable way of interpreting the 95% confidence interval. There are other ways of interpreting it as well, but I want us to think about this particular way and ask ourselves, if we're really interested in what the population mean is taking a single sample from the population, estimating the population mean with the sample mean, using the data in that sample mean to build the 95% confidence interval, is that the best way to hone in on the population mean if the population mean really is the thing that you're interested in? I would argue we're usually not interested in the population mean, but in the process of exploring this, I think I'll demonstrate to you some things about how statistics operates. So, especially with reference to the central limit theorem. So, let's take this data file that we have and let's make a new column in the data file. So, my data file is dat, and I want to calculate a new column. So whenever you make a new column, you put the data frame, a $sign, and then give this thing a name like X bar. X bar is just an X with a bar over it. That's the shorthand symbol for mean. And what we're going to do is we're going to use the assignment operator. And what we're going to want to do is we're going to want to find the mean of draw 1, comma, draw 2. Let's see if that works. No, I didn't put a 1 there. No. Oh, I know what. No. I'm losing my mind. Ah. That's for a single column. All right, do this instead. Okay, so you have to put in the whole column name, dat $sign draw 1 plus dat $sign draw 2, and then divide that by 2. That will give you the mean. Then do dat to see if that actually did what it said it did. So 7 and 5 is 12. 12 divided by 2 is 6. 3 and 10 is 13. Divided by 2 is 6.5. 10 and 2 is 12. Divided by 2 is 6. So you can verify for yourself that it's actually doing what it says it is doing. This is all you need to do for the moment. Yeah.
I did it and then I got that error.
Let me see what your thing. Draw dot 1. Yours is draw dot 1, draw dot 2. When you make column names in Excel, it's better to not put spaces in there because when it imports those into R, it will put dots in there in the place of the spaces, and then you have to remember to put the dots in there. So you'll see that I oftentimes, I practically always, whenever I create a data frame in Excel, I always just make it lowercase with no spaces. Then it just simplifies my life when I get into R. So that's the issue. So you got the dots in there. All right, everybody with me here? Yeah.
The column X4 isn't showing up.
Oh, okay. So, and you ran that line?
Yeah, that's what happened when I did it.
Oh yeah. You didn't ask for it again. Go and ask for that again. So just type that right there. This is what you showed before.
Yeah, it had the blue show up. It had like the blue line show up whenever I entered it.
Yeah. So just run that so you can see what it looks like.
Just right.
Yep, right there. Yeah, there it is.
Okay.
You had it do the thing, but because it was an assignment, you basically said assign this to this column, but then you didn't ask to see the data file again. So you have to see it. you guys will notice that whenever I ask R to do something, the next thing that I always do is I always go and check R to make sure that it did it and it did it the way I think that it did it. So not only do I get it to show me the data set that's now been changed, you also notice that I do some of the math in my head to make sure that not only did it do something, but did it do the thing in the correct way. I'm always checking R because I have an inherent distrust of computers. So it's a wise thing to do to always look at the data set and um, and check that, verify that it actually did. Thank you. Struggling with words today. Okay, so what we have here is we have 30 observations from card decks. If we were going to calculate the population mean, so if we think of that card deck as a population, that we want to know the average value of the cards in that population, there are 4 suits. The 4 suits have an ace, a 2, a 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? If we count Jack, King, and Queen as 11, 12, and 13, and the ace as 1. So, and there are 4 suits of this, so there's just this thing repeated 4 times, right? So if we want to know what the population mean is of a deck of cards, we have the whole population. We can just calculate it directly. It's not that hard. 1 plus 2 is 3, 3 and 3 is 6, 6 and 4 is 10, 15, 21, 28, 35, 36, 36, 45, 55, 66, 78, 91. Wait, that's not right. 1, 3, 6, 10, 15, 21, 28, 28 and 8 is 36, 36 and 9 is 45, 10 is 55, 11, 66, 12, 78, 13, 91. Okay, 91. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13. Divided by 13. So this is the adding all those numbers up, dividing by 13. Oh, the average is 7. It's the value that is in the middle. So we know what the population mean is for this deck of cards. The population mean is 7. So what we did was we dipped into this population, we pulled out 2 cards, and then we calculated the mean of that. We can then see what the results of that. In some cases we got 6, 6.5, 6.0, 5, 5, 3, pretty far away from 7, 9.5, 10.5, 8.5. Seldom do we actually get the real number 7. But now what I want you to do is I want you to take the mean of x bar. Except you need to put dat $x bar. And what I get for the mean of x bar is 6.36. So the mean of the sample means is 6.37, which is pretty close to the actual population mean, but it's certainly not perfect, right? get the sum of the draw one column and call that add 1. So use the assignment operator. So get that column, do add 2 to get the sum of the draw 2 column. Use the assignment operator to add those two things together. And then figure out what the total sum is and see if that comports with what you think it's going to be. 191, that seems like about right. All I'm doing is I'm adding up all of the values. I'm adding up all the values, and I am now going to divide that by 30. So take total sum and divide it by 30. Because we have 30 values total in this data set. And you're going to find that it should be the same number because it's all the same data. Turns out if you average the average, it gives you the same value as adding up all of the raw data and averaging that. In this case, they're the same value. By adding the sum of the averages, we got that same value. Here we also got this value. But now, because we have these 30 values, we can figure out what the 95% confidence interval is around that number. If we were to look at the 95% confidence interval around this first number, what's the t-statistic that we would use to do that calculation? So this first sample is a 7 and a 5. So let's just do the calculations really quick. 7 and 5, that adds up to 12. The average then is 12 divided by 2, which is 6. To get the variance, how do we get the variance?
The observation divided by sample.
Nope, it's the observation minus the mean squared. So this differs by 1, this differs by 1. When we take that difference, this is actually a plus 1 and a negative 1. When we square that difference, it just gives us 1. That gives us 2. That sum is divided by n minus 1, which in this case is 1. So the sample variance is 2. The standard deviation is the square root of 2. Can somebody give me the square root of 2? I don't have my... Anybody? 1.41. So the standard error is the standard deviation divided by the square root of n. This would be 1.41 divided by 1.41, which is 1, which is weird. So now we know what the standard error of the mean is, so we have to go back to that presentation that we were looking at the other day. Let's go and find it. And we need a t-table. So let's go down and find the t-table. Where did the t-table go? And what we have is we have 1 degree of freedom. And if we want to test this at the level of 1 degree of freedom, because we have a sample size of 2, we would multiply that times 12.7. So for this data set of two values, we basically have a confidence interval which is 6 plus or minus 12.7. That value also includes the value of 0. Now we know for a fact that the value of 0 is not the average of this thing. So this would be 8. This is a 95% confidence interval that ranges from 6 to 18.7 at the high end to minus 6.3 at the low end. That's a huge range. Is the population mean in that range? Is 0 in that range? Does using the 95% confidence interval on this small sample do a very good job of telling you what the population mean is? No, it doesn't. Why? It's too broad because our sample is too small. So now let's go back to R and do some on-the-fly scripting. Give me a minute. Don't copy this just yet. Yes, okay, do that. So all I'm doing here is I'm taking those two columns. So I'm making a new data file called dat2. I'm going to concatenate the data that is in draw 1 and the data that is in draw 2 so that I've basically taken those two columns of data and put it all into one vector. Okay? And then when you see it, you should just have 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24. You have 30 values. Yeah, you had a question?
Doing it up high then or down low?
Oh, no, I always edit in the editor window
Right.
and then execute it. Wait, did I do that or not? Oh, I did it down low, didn't I? What am I doing? Okay, I don't always do that. But yeah, you should do it up here. Okay, so you've done that and you've verified that it worked. Okay, there it is. Everybody get this? Yeah. Huh?
You have 1 and 18. Like 1 and 25.
Oh, it's because your window is broader.
Okay, it's just.
Yeah, it's just counting the numbers. Watch plane. Run it again. Just window width. Yeah.
I'm not sure if I typed it in wrong, but I'm doing an error.
Okay, let me see your original data file. Okay, hold on. Dat. Draw dot 1, draw dot 2. Oh, interesting. Okay. What happened when you ran that line? Oh, you didn't run it. You have to run it after you type it. Typing it in doesn't do the trick. You have to run it. There you go. Now do it. There you go. Yeah. Anybody else? Okay. We already know what the average is of all these things because we just did that a few minutes ago. But we can also do things like summary dat2. That isn't actually what I wanted it to do. How much time do we have? All right, so let's do some math with with all of this. So dat2, so do you guys see what I'm doing? Oh, okay, that didn't work. I just have to pay attention to all these things. Whoop. Ah, I see what I did. No. There it is. Okay. I'm having parentheses issues this morning. So what I'm basically doing is I'm building up an equation to calculate sample variance. So what I've done is I've put the numerator of sample variance, which is the values minus the mean of those values, and squared that. So I'm just adding, I'm basically building up an equation to allow us to calculate sample variance. I verified that that did that. So what I can do is I can then put sum in front of that, and if I do that, that should reduce it to a single number. Which looks like a wrong number. So what am I doing wrong there? Oh, I need to put parentheses around the whole thing. So, yep. Once again, parentheses are my bane. So parentheses there and parentheses there. What's that? Oh, I see what I've done. No, I don't see what I've done. What the heck? Oh, why? I am missing the parentheses. Okay, so let me go back and fix that since I'm actually getting it to run. Okay. All right. 390.9, right? Okay. So that's the sum of the things that were in the numerator. Now to get the sample variance, we just have to divide that by the sample size. So once again, put this all in parentheses, put that all in parentheses, and then divide by, in this case, 29, and that should give us the sample variance, which is 13.48. Okay, all right. If I could learn how to type, we would be moving through this faster. Save this R script. We're going to come back to this on Monday. Also, I'm going to have a homework assignment for you that talks about central limit theorem, calculating confidence intervals and things like that. That will be up probably in the next couple of hours. It relies on you going to the box outside my office and getting decks of cards. If you don't have a deck of cards sitting in your dorm room, you can just come by my office and get a deck of cards. We're going to do some card flipping exercises to illustrate these points that we'll continue talking about a little bit on Monday. So pack up your decks of cards and hand them back in. You will need R for the homework assignment. But I'll put an R script on there for you to operate from.